first section of 6.1 is going to set us up for the rest of the chapter. All right, so we're going to do some square roots and some different radical expressions. All right, when I ask for the square root of 9, okay, I'm not really asking for a number yet. When I ask for the square root of 9, what I'm looking for is what number times itself will give me 9. When we do a square root, we're looking for what times itself give me 9. So we know that the square root of 9 is 3, because 3 times 3 gives me the 9. All right? Cube root of 27. Cube root of 27 is I'm looking for what number times itself that gives me 27. So there's a number times itself that gives me 27. If we do a little thought in our head, 3 times 3 times 3 is 27. All right, to the fourth root of 81. Again, what number times itself give me 81? And if I do a factor tree, I get 9 times 9, which is 3 times 3 times 3 times 3. Wait a minute, 3 times 3 times 3 times 3 is 81. So the fourth root of 81 is a positive 3. All right, fifth root. What times itself will give me 243. And if you look at the pattern, that's also 3. So the fifth root, you're looking for the same number multiplied times itself, a total of 5 times. All right, let's move to variables. Square root of x squared, we've done a whole bunch of times. We know is x. All right, but now if I make my exponent different, the square root of x to the 10th, I need x raised to some power, they'll give me an x to the 10th. All right, if I go down here, we got two concepts. I have x squared times x to the third and x squared raised to the third. We need to recognize that when you have the same base multiplied together, you add. When you have a power raised to a power, you multiply. So when I take this apart as x times x to a power times x to a power, I need these two numbers to be the same and add to give me 10. So I'm going to say the square root of x to the 10th is x to the 5th. Because x to the 5th times x to the 5th is your x to the 10th. Cube root of x to the 12th. I need that same number. X to something times x to the same thing times x to the same things. It gives me x to the 12th. And for it to work, all those have to add this to give me 12 and be the same. So I'm going to say x to the 4th. All right, if you look, 12 divided by 3 is 4. Going back. We put a 2 out here. 10 divided by 2 is 5. The square root has an imaginary 2. 2 divided by 2 is 1. So what you're going to do, if it works evenly, is we're going to divide. So x, the fifth root of x to the 25th is x to the 5th. Because if I write this out 5 times, and I add all those exponents, I get my x to the 25th. All right, last one, I believe. Yes. Just a quick little lesson. When I have multiple terms underneath a root, I'm going to write this as 3 separate roots. All right, I'm going to take the 4th root of 16, the 4th root of x to the 4th, and the 4th root of y to the 12th. All right, if I don't see 16, I'm going to do a factor tree. Oh. So the 4th root of 16, I'm looking for a group of 4, is 2. The 4th root of x to the 4th, I divide 4 by 4, and I get x to the 1st, which we normally don't write. Then lastly, 12 divided by 4 is y to the 3rd. All right, so when you have ones that work cleanly, and that's what this lesson is, you divide your exponent by your root. Next class or next lesson we get, however it's going to be, they're not going to divide in evenly. And we're going to have to do something to force them to work that way. All right, so there's the first lesson. You should have a handful of problems for homework, which will be due at some point, and I'll put that in the classroom.